Okay, here's a combined gas law problem where you're going to solve for temperature, or T. Now remember, when you're doing combined gas law problems or anything that is a gas problem related to temperature, you are going to convert anything that was in Celsius into Kelvin. Now if you didn't know that ahead of time, now you do. You take the Celsius temperature, you add 273, and that gives you the temperature in Kelvin. All right, so just keep this in mind when it comes to any kind of combined gas law problem or even the ideal gas law. Okay, so we'll take a look at this problem and see what to do. A gas occupies a volume of 445 milliliters at 273 Kelvin and 81.0 kilopascals. Now this is kind of cool because they've already converted into Kelvin for us. We don't need to do anything. So let's see what comes next. What is the final Celsius temperature? Uh-oh. All right, I spoke too soon. Check it out. We're going to need to convert from Kelvin back into Celsius at the end of the problem because that's what they want us to write for our answer. So they say, what is the final Celsius temperature when the volume of the gas is changed to 180 milliliters and a pressure of 42.1 kilopascals? Okay, so the first thing to do is to make sure that you understand what the combined gas law is. So you have a set of initial conditions, and that little subscript 1 reminds you that that's the initial conditions. The 2 that I'm writing here in the subscript position, that 2 represents the final conditions. So you have to make a distinction between initial conditions and final conditions. So to start off, these 3 numbers up here indicate the initial conditions. Milliliters indicates the volume. Kelvin indicates the temperature, and kilopascals indicates the pressure. I like to label things so that way when I substitute into the equation, it makes my life that much easier. All right, so make your life easier as well. Just a little bit of friendly advice. Okay, now this number right here is the second volume, right? This is the final volume. And this over here, this number is the final pressure. So what we're asked to find is T2. That's the only number that was not explicitly mentioned in the problem. They want us to find the final temperature, of course, but they didn't give us a number. Okay, so with that in mind, I'm going to take my blue pen here and sub in the numbers that I just found from decoding the problem. All right, this decoding step can be tricky, so give yourself a little patience, to get this down. All right, and label as I label, because then you'll also find that it gets a lot easier to substitute the right number in the right place. So I'm going to substitute in 81.0 kilopascals as my pressure. The volume is 445 milliliters. The temperature initially is 273 Kelvin. Now, what's important about these kinds of problems is that you keep the units consistent. Note that I have kilopascals, milliliters, and Kelvin. So you better believe that over here, my final units better be the same. Otherwise, this won't work. All right, so we have 42.1 kilopascals. Our volume is 180 milliliters. And that matches with the ones on the other side. If they didn't match, then you'd have to make some kind of conversion until they did match. All right. Now we're looking for T2. We don't know what that is, but that is the basic setup for the problem. Okay? All right, so we're going to move this up a little bit, and then we're going to do a little bit of algebra in order to figure this problem out. Now as a shortcut, you can switch the positions of these two when there is an equal sign in between. Don't ask me how. I'm just telling you a fun little trivia fact about algebra. I could prove it to you, but this is not a math class. This is a chemistry class. So let's see. I'm just going to switch these two, put this one on top, and then put these two numbers down where the T2 was. Okay, that sweet little maneuver saves us a little bit of time. And as you know, sometimes on tests, time is really, really important to save when you can. All right, now to get T2 by itself, I'm going to need to make sure I multiply by 273. So I'll multiply both sides by 273. These cancel, and now we're looking good here. Okay, so all I need to do now is use my calculator and figure out what this part is, and then I'll have my answer. So I'm going to take 42.1 times 180 times 273. Then I'm going to divide by 81 and divide by 445. So our final answer is 57 point, well, let's just round to the first, to the 10th place there. So it's 57.4. That's the temperature. Now, you may ask yourself, well, what are the units? Remember, the units have to be consistent. So if this is in Kelvin, which it always should be, then the temperature here should be in Kelvin. But wait, there's more. Remember, the original problem wanted us to find the Celsius temperature. Okay? So this is a little bit more tricky because even though we found an answer, that's not the answer they were looking for. They want the temperature in Celsius. Okay, well, if we want to figure out the Celsius temperature, we have to do the reverse by taking the Kelvin temperature and subtracting 273, and then that will give us degrees Celsius. Okay, so we'll take our 57.4, we'll subtract 273, and then that's going to equal degrees Celsius. All right, so we're going to take our answer. Nice little shortcut here, second function answer. That will repeat the number that we just entered. Then we hit the subtraction key, 273. So the temperature is equal to negative 215.6 degrees Celsius. Now that is our final answer. Okay? So just to recap, the problem required us to find the final temperature. And what we did was we first decoded the problem to figure out what all the variables were. Then we wrote down the formula, we substituted in the values where needed, and we checked along the way just to make sure that the units matched. We always use Kelvin as our temperature, and then we did a little bit of algebra to figure out that the final temperature is 57.4 Kelvin. But wait, there's more, because we had to figure out the degrees Celsius. So we took that temperature, subtracted 273, and that is our final temperature in degrees Celsius. All right, so go ahead and watch the video again if this was a little bit much to swallow in one, in one viewing. And if you need more help, just click on another video and watch another, problem that I solved. Another good thing to do is download the free worksheet that comes with this and see if you can duplicate the steps that I made and see if you get the same answer that I did. And if you can duplicate this, you're well on your way to mastering the combined gas law.